Let's look at factorizing. So factorizing is like the opposite of expanding. So for instance, if we had the bracket 2 and then brackets x plus 1, then if we were to expand this, we would end up getting 2x plus 2. And so going forwards is expanding, and what we're going to look at is how we can go backwards and factorize. So in the first example, we have 12 plus 12x. Now the way we factorize is we look at each of the terms and we see what is common in both of those terms. In this case, we see that the number 12 is common in the first term and the second term, and so we can factorize that out. So we write 12, and now in brackets, we write what we multiply 12 with to get this first term. So 12 multiplied by 1 gives us 12. And so inside the bracket, we would write 1. And now we think about what we multiply 12 with to get 12x. And that would be x. So inside the bracket, we write plus x, and we're done. We factorize 12 plus 12x to get 12, and then in brackets 1 plus x. If we were to expand this, we would end up getting 12 plus 12x. Looking at the second example, we've got x to the power of 5 minus x to the power of 3. And so in this case, we need to think about what's common in both of these two terms. We see that both of them have x in them, and both of them have a different power of x. The first term here is x to the power of 5, so that's x multiplied by itself 5 times. And the second term is x to the power of 3, and that's x multiplied by itself 3 times. So both of these terms have 3 x's common, and so we can take that out. So we write x to the power of 3, and now in brackets, we need to write what we multiply x to the power of 3 with to get x to the power of 5. And so to get the remaining power here, we would need x squared. Since when we multiply these two together, we add the indices, and so 3 plus 2 gives us 5. Now we've got a minus sign in between these two terms, and so we now need to think about x to the power of 3, what do we multiply it with to get x to the power of 3? And that is 1. And so we end up with x to the power of 3, and then in brackets x squared minus 1. And if we were to expand this out, we would end up getting x to the power of 5 minus x to the power of 3. Looking at the next example, we've got 6x squared y to the power of 3 plus 8xy squared. So in this case, we've got a combination of numbers and different letters. So we should factorize by considering each of those one by one. So let's start with the numbers. In the first term, we've got 6. In the second term, we've got 8. And so we look for the highest common factor of 6 and 8, and that is equal to 2. So we can factorize 2 out from both of these two terms. And so in brackets, we would be left with, so 2 times 3 gives us 6. And so we would have 3x squared y cubed plus, and so 2 times 4 gives us 8. So 4xy squared. And we see that both of these numbers, 3 and 4, don't have any factors in common other than 1. Now we're going to factorize further by looking at the x's. So in the first term here inside the bracket, we've got x squared. In the second term, we've got x. So both of these terms have a x in common, and so we can factorize that out. We end up with 2x, and now we need to think about what do we multiply x with to get 3x squared y to the power of 3. And so that would be 3x y to the power of 3. Since if we multiply x with this, we would end up with 3x squared y to the power of 3. And then we have plus 4. And now since we've factorized the next out, we don't have any x's in this term, and so we're just left with 4y squared. And then finally, we can now factorize out the y's. So in the first term inside the bracket, we've got y to the power of 3. In the second term, we've got y squared. So both of these terms have y squared in common, and so we can factorize that out. So we now have 2xy squared, and in brackets, we're left with 3x. Since we've taken y squared out, we're left with y plus 4, and since we've taken y squared out from this term, there are no y's in this term anymore. And so factorizing 6x squared y cubed plus 8xy squared, we end up with 2xy squared, and in brackets 3xy plus 4. And if we were to expand this out, we would end up getting what we started off with. Looking at the final example here, we've got 10a squared b to the power of 5 all over 3x minus 5ab all over 7x. So we've got two fractions here, and we're now going to factorize both of these. So looking at the first fraction, in the numerator we've got 10, so let's start with the numbers. And in the second fraction, in the numerator, we've got 5. So from both of these fractions, from the numerator we can factorize a 5 out. We also see that in the numerator, both have a's in them. In the first term here, we've got a squared. In the second term, we've got a. So we can factorize a single a out from both. Then we also see we've got b to the power of 5, and we've got b in the second fraction. So from both of these terms, we can factorize a b out. Now looking at the denominators, so in the first fraction, we've got 3x. In the second fraction, we've got 7x. Both of these denominators have x in common, and so we can factorize x out from the denominator. So finally, in brackets, we would now write what we multiply 5ab over x with to get 10a squared b to the power of 5 all over 3x. So 5 times 2 would give us 10. So we have 2 in the numerator. And then a times a would give us a squared. So we would write a here. And then b times b to the power of 4 would give us b to the power of 5. So we need to write b to the power of 4 here. And then in the denominator of this fraction, we see that we have x on the outside, so x times 3 would give us 3x, and so we write 3 here. Then for the second fraction, so we've got a minus sign in between the two terms, and now in the second fraction, we see that in the numerator, we've got 5ab, so 5ab times 1 would give us 5ab. So we would just write 1 in the numerator, and then in the denominator, since we factorized an x out, we need to think about what do we multiply x with to get 7x, and that would be 7. So we write 7 in the denominator, and we're done. We factorized these two terms to give us this. And if we were to expand the brackets here, we would end up with what we started off with.